In this tutorial, I'm going to solve question from your toy sheet 6 on organic chemistry. She's saying, give correct Iupac names for the following compounds. Okay, so we've been given these compounds here, and we are to give their Iupac names. Okay, so what are the steps that we follow when giving an Iupac name for an organic compound? Okay, so the first thing that we need to do, we identify the longest hydrocarbon chain. Okay, so identify the longest hydrocarbon chain, isn't it? The longest hydrocarbon chains. Okay, hydrocarbon chain. Okay, so now once you identify the longest hydrocarbon chain, then you have to check if your compound is having functional groups. Okay, so in the case where you're having a compound with a functional group, you need to identify the functional group with the high purity, isn't it? So identify the functional group with the high purity. Okay, yeah. Then once you identify the functional group with high purity, what you are going to do is to number it, isn't it? So now when numbering, you have to make sure that you get the functional group to the lowest number possible. So you number it, okay? So once you number it, then you arrange the substituents. So arrange the substituents that you're having in alphabetical order. Alphabetical order. Then you would have named your compound there. Okay, so let's start with the first one. Let's do all this on the first compound there. So we are starting with the first step to identify the longest hydrocarbon chain. Okay, so which path can we use? We can use this path. So this can be our carbon number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8. Or we can say this is our carbon number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8. Either way is going to be correct, but that is your longest hydrocarbon chain. So I'm going to follow this path here. Okay, so I'm saying this is my carbon number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8. Okay, so for a hydrocarbon with 8 carbons means that the name that is going to carry is an oct. Now, here I'm not having any double bond, so it means that I'm going to have an alkane, isn't it? So it's going to be an octane. Now, the second step that I'm going to follow is to identify the functional groups that I'm having. So you can see here I have this functional group, the ketone there. So a ketone functional group is going to look like this. Yes, this is the R group and that's the R group. That's a ketone, right? For an aldehyde, it's going to look like this. We're going to have a hydrogen there and then the R group. That is an aldehyde. Like this one here, that is an aldehyde, right? Even this one here, that's an aldehyde. But this one is a ketone and the other one is a ketone, right? So that's what I have. So it means that I have a ketone and also an alcohol here, okay? So we need to ask ourselves between an aldehyde and alcohol, which one has high purity? Okay, so if you follow the purity table that you are usually given in an exam, you notice that a ketone has high purity than a hydroxide group there, or an alcohol, right? So what you are going to notice that this one, an aldehyde, a ketone, sorry, is going to carry the parent name because it's the one with highest purity, right? So it means that this compound is supposed to end with 1 like this. Okay, so if a ketone is having high purity, it means that it's carrying the parent name and the compound is going to end with 1. Okay, that's the suffix name for a ketone, right? And then an alcohol, in this case, is a substituent because we're having a functional group with higher purity than an alcohol. So when an alcohol is a substituent, it's going to carry a word hydroxyl. Okay, so it's going to be an hydroxyl. When it's a parent name, it's going to be an O, like that. Okay, so in that case, the alcohol is going to be hydroxyl. Okay, so now we've identified the functional group with highest purity, which is the ketone here. So now here we go to the second step, which is saying number it, isn't it? Number it. So we are saying we have to number the compound to make sure that we get the lowest number possible to the functional group with highest priority. So remember, we can number this one in two ways. So we can start from this side. We can say this is our carbon number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, or we can start from this side. Now, if you start from this side, you notice that the ketone group with the functional group with highest priority, you are finding at position number 1. So this is number 1, number 2, number 3, number 4, number 5. But if you start from this side, going the other side, you notice that your functional group, which is a ketone with high priority, is going to be at position number 4, isn't it? So this is 1, 2, 3, 4. So the one with the lowest number possible is 4 there. So it means that numbering, we're going to start from this side, going the other side, right? So this will be our carbon number 1, number 2, number 3, number 4, number 5, number 6, number 7, and that will be our carbon number 8, like that, right? Okay, so now we've numbered our compound. So what we need to check are the substituents that we are having. So here we are having a hydroxide substituent and an ethyl group there, isn't it? Okay, so let's identify the positions where these substituents are. Okay, so we are saying at position number, okay, so at position number 3, so this carbon number 1, number 2, number 3. So we are saying at position number 3, we have an ethyl group. Okay, and then we are saying at position number 7, you can see there, at position number 7, we have a hydroxyl group. We are saying if an alcohol is a substituent, it's going to carry the name a prefix name hydroxyl, like that, right? When it's a parent or when it has high purity, it's going to carry a suffix name or L, like that, isn't it? So in that case, we follow hydroxyl, right? Okay, so we have the numbered our substituent, the position where they are. Now we can name our compound, isn't it? So now when naming the compound, we start with the substituents that we have in. So we number the we arrange the substituent in alphabetical order. So here we're having this substituent with an E and this one with an H. So you notice that on the alphabet, E is going to come first than H. So when naming, we have to start with an ethyl there. So we're going to say 3 ethyl. Okay. And then at position number 7, we're having a hydroxyl. And then here we are having, now, two ways you can show that this functional group is at position number 4. So within this molecule, we can just say at position number 4, I'm having a ketone, isn't it? Which is the functional group in this case. So we can say 4. Now, I bring my parent name there, which is octane, octanone, like that. Okay, so this is one way I can name it. The other way, I can show the position of this ketone within the octane ring, okay, which is the most recommended one. So I can name it like this. So I have 3 ethyl, okay, then I have 7 hydroxyl, okay, then I can say octa. So now I want to show that at position number 4, I have a ketone, which is 4 known, like that. So either way is going to be correct there. Okay, so that's how we can name our first compound there. Okay, so let's go to the second one. All people are clear. Go to the second one, which is this compound here. So we follow the same step. Identify the longest hydrocarbon chain. So you notice that this would be our carbon number 1, number 2, number 3, and our carbon number 4. So we have a butane there. So because we don't have any double bond, so we are having a butane, like that, right? Okay, so now let's identify the functional groups that you're having. So we're having an aldehyde here and the ketone there, isn't it? And an ethyl group, right? So now the question is between an aldehyde and the ketone, which one has high purity? Okay, so if you follow the table of purity, you notice that an aldehyde, okay, is going to have high purity than a ketone. And if an aldehyde is having high purity, it's end with OL, like that. Okay, and then if a ketone is a substituent, has lower purity, in this case, going to carry the name oxo, like that, isn't it? So now we can list the we can number it, isn't it? So let's start with the numbering. So we can either start from this side or the other side. So if you start from this side, means that this is our position number 1, number 2, number 3, number 4, isn't it? So that will mean that we are saying at position number 4, that's where we're having the functional group, isn't it? which is not going to be okay. But if we start from the other side, we are saying this will be our position number 1, this will be our position number 2, number 3, number 4, isn't it? So we are getting the lowest number possible 1 when we start counting from the other side. So it means that our aldehyde function group will be at position number 1, rather than it being at position number 4. So we start numbering from this side. So now let's get the substituent that you're having. So we are saying this is carbon number 1, this is carbon number 2, isn't it? So at carbon number 2, notice that we are having an ethyl group, right? And then what else? At position number 3, we have a ketone, which we are saying when it's a substituent, it carries the name oxo, right? So we have an oxo group at position number 3. So now we can name our compound there. So our compound is going to be, so we are saying we follow the alphabetical order, starting with the substituent that you're having. We're having an ethyl. E starts first with T. If we compare it E and O on the alphabet, E starts first, then O for is at the end somewhere there, isn't it? So we are going to start with the first one there, which is 2-ethyl. Okay, then we are saying at position number 3, we are having an oxo. Then we say this is a butane, isn't it? So it's going to be a butane. Then we end with the AL there, indicating the butano that we are having, isn't it? Or we can say this can also be written as 2-ethyl. Okay, then 3 oxo. Okay, so if you want, you can indicate the position of your ketone group, which is at position number 1. So you can say 1-butano like that. Okay, or you can say this is 2-ethyl. Okay, then we have 3-oxo. Then we say butan. Then 1-O like that. Okay, so either ways, all these are going to be correct in that case. Okay. Okay, let's move to the next one. Okay, so the next one there, we need to identify the longest hydrocarbon chain as well. Okay, so if you follow this path, so you're saying this is position number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, right? If you start from this side, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the longest hydrocarbon chain is to start from the other side, this side, isn't it? Okay, so now let's identify the numbering. Let's identify the functional groups that you're having. So you're having a halogen there, and an aldehyde. Definitely an aldehyde will have the highest purity than a halogen, isn't it? So it means that when numbered in, we start from this. So this is our carbon number 1, number 2, number 3, number 4, number 5, number 6, number 7 here. This is number 8, and then that will be our number 9, isn't it? So a 9-carbon hydrocarbon compound, okay, it's going to be called a none, isn't it? So it's going to be a none. Now we have a double bond there, so it means that this is going to be a nonane, isn't it? Okay, now since we are having an aldehyde as the one with highest purity, so it's going to end with the AL like that, isn't it? So we are going to have noneno like that, right? Okay, so now let's number it. Let's identify the substituent that you're having. So you're having a substituent here. So we've numbered it. This portion number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, and number 9. So you're at portion number 6, you can see there, you're having a substituent, which is an ethyl group, right? Portion number 6. And then at portion number 7 here, okay, we are having at portion number 7, we are saying we have, okay, so this is portion number 1, 2, 3, 4, 5. So this portion number 5, sorry. Okay, this portion number 4. So at portion number 4, we're having an ethyl group, and then at portion number 5, we're having a chlorine, isn't it? Okay, a halogen, so it's going to be chloro there. Okay, so we're having a chloro at portion number 5, right? And then at this same portion number 5, we're having an alkene, okay, a double bond there, right? Okay, now if you look at this double bond here at portion number 5, okay, so in this case the double bond is it's not carrying high purity in this case. It's a substituent as well. So when a double bond is a substituent, so we are saying also at portion number 5, we have an E. Okay, so remember that when a double bond is a it's a parent name is going to end with ENE like that. But when it's a substituent, it's going to be EN like that. So we need to show that at portion number 5, that's where we're having the EN there like that. Okay, so that's what you're having. Okay, then also when whenever you're having a double bond, you can give the isomers. Okay, so there are two isomers that we have. We can have what we call the cis isomer and the trans isomer. Okay, so notice that how the cis isomer is going to look like. So let's say we have this carbon. Remember, we are saying at the position where we're having a double bond. Okay, so let's say to this carbon we attach an R group, and then here we attach a hydrogen, and then here we attach the R group, and then here we attach the hydrogen. Then let's have another a compound which is looking like this. Then here we attach the R group, here we attach the R group, here we attach the hydrogen, then there we also attach the hydrogen. Notice the difference here, the way the atoms are arranged, the way the atoms are packed. Okay. Okay. So now notice that the way the atoms are arranged, these group same atoms are on the same side. Okay, so you have this R group and R group. So a hydrocarbon, a longest hydrocarbon chain is an R group. You can just indicate an R group for us to avoid writing all those structures, isn't it? So you notice that if you have an R group there, an R group, or any other groups that are the same, are on the same side, and then you have same atoms or same groups again on the same side. So in this case, we're having same hydrogen on the same side and same R groups on the same side. So in this case, the isomer that you're going to get here is the cis. Okay, so we get the cis isomer there. But for this case, if you're having an R group, okay, on the different side than the other one, okay, so you can see this, the R group, the other side, the R group as well. Okay, so it means that we have the R group on different sides. So in that case, we are getting a trans isomer. So this is a trans, right? So in this case, if you look at this compound at portion number 5, that's where we're having a double bond. So we are saying at portion number 5, what type of isomer are we having? So let me just rub there. Okay, so you notice that if you look at this double bond, we have a hydrogen here, right? And a hydrogen there, right? Okay, so you notice that we have hydrogens on the on this on the same side, isn't it? So we have hydrogen on the same side. Okay, then this side we're having a chlorine there. Okay, and then this side we're having an R group. So in this case we are not having anything of the same, isn't it? Okay, so this side is an R group, this side is a chlorine there. So in such a case we cannot designate the cis and the trans, isn't it? So in that case we are not going to have the cis and the trans isomer. So there will be a time there whenever you have the double bond, you have to check whether you're going to get the cis and or the trans isomer. So in that case, since we are saying we have chlorine and the other groups which are different there, and also we have hydrogen and hydrogen. Hydrogen and the hydrogen are the same, but chlorine and the other group are different. So in that case, we cannot assign the cis and the trans, right? So what we are going to have, we are only going to consider the substituent. Okay, so this is still position number 5. Okay, and then we are saying this is portion number 6, this is portion number 7. Okay, so at portion number 7, notice that you're having a methyl group there. So we have a methyl group at portion number 7. Those are the substituents that we are having, right? So now we can name our compound. Okay, so we start with the lowest purity, which is the C, isn't it? C will come first than E. Okay, then we can say at portion number 5, we have a chloro. Okay, then at portion number, so for this En, okay, I can indicate it on inside there, the parent name there, because we are saying the double bond is inside, is embedded inside there, inside the entire compound, isn't it? If we show it outside, means that we are saying the double bond is outside the compound like that, like the way this substituent. But since it's embedded inside, we have to indicate it inside the what? The compound as well. So I'm going to show you how we are going to indicate it inside the compound. Okay, so we're saying at portion number 5, we have a chloro. Then at portion number 7, right? Okay, so before 7, we have an ethyl group there. Okay, so at portion number 4, we have an ethyl group. Okay, then at portion number 7, okay, so at portion number 7, we're having a methyl group, isn't it? Methyl group, okay? Then now we can bring the compound there, which is known, isn't it? Okay, so we can say this is known, okay? So now, known, okay, so now I want to indicate where the En is. So remember the En here is a substituent in this case, isn't it? So it's at portion number what? So I can say known, then I indicate portion number 5, I am having En like that, isn't it? And then at portion number 1, that's where now the AL is coming from. So I can name it like this, isn't it? So I can have 5 chloro, 4 ethyl, 7 methyl, then known. So I want to show the position where the En, since it's a substituent in this case, where it is. So it's at portion number 5, isn't it? Or I can name it like this. So I can say 5 chloro, okay, then 4 ethyl, okay, then 7 methyl, okay, then I can indicate this 5, isn't it? Say at portion number 5, I'm having a double bond, non like this, isn't it? And then I can say at portion number 1, I have an O like this, isn't it? So either way is going to be correct like that. Okay. So let's do the last one. Then I'm going to show you how you can access the list of the video solution on the website. Okay, so let's start, finish the last one. Okay, so now we have a situation here where we're having a cyclic ring. Okay, so now when we have a cyclic ring, it means that most of the time you need to count the number of carbons that are in that cyclic ring. Okay, so here we can see it's a benzene ring, isn't it? It has 6 carbons. So in this case, the benzene ring is going to carry. Okay, so you're having a benzene ring, but again, also here we notice that this is a hydrocarbon, isn't it? So if a hydrocarbon, it's having the highest purity here. So in this case, the benzene ring is going to be the substituent in that case. But if you didn't have high purity here, it means that the benzene ring was going to be considered as a parent name. So in this case, the benzene ring is a substituent. And we know that when a benzene ring is a substituent, it carries the name phenyl, isn't it? It's a phenyl ring, right? So when it's a substituent, it carries the weight phenyl, like that. This is a benzene ring. When it's a substituent, it carries the name phenyl. Okay, and then if you look at the hydrocarbon that we are having, so we are saying this is the highest purity, isn't it? Right? Which is the aldehyde. So this will be our portion number 1, number 2, number 3. Okay, so at portion number 3, that's where we're having the phenyl ring attached to it, isn't it? Right? Yeah. So we have a phenyl group. Now here we have a hydrogen. Here we have the R group. Okay, and then here we also have a hydrogen, and then this side we have the R group as well. So it means that we have the R group there, the R group, hydrogen, and the hydrogen. So which arrangement is that? It's the trans, isn't it? You can see atoms arranged on different position, the R group and the R group there on different position. So this is the trans isomer. So you need to show as well that we're having a trans isomer. So this is a trans. Okay. Now, also apart from the trans, we can also designate an E or Z, okay? So for E and Z, if atoms are the same on the same positions, like this one here, we have R group and the R group, such an isomer is going to be called the Z isomer, isn't it? Then for atoms that are on different sides, such an isomer is going to be called an E isomer. So in this case, we can also designate E or Z as well. Okay, so let's do that. Okay, so now we are saying the longest hydrocarbon chain is a propene, isn't it? 3 carbons, it's a propene, isn't it? So now here we're having a double bond, so this is going to be called a propene like this, isn't it? Right? Now we're having an aldehyde, so this is going to be called a propano like this, isn't it? Or a propeno like this, isn't it? Okay, so the substituent that you're having is just a phenyl group. So we can say this is a trans, and then at portion number 3, we're having a phenyl group, isn't it? This is a phenyl group, the benzene ring is a phenyl group, okay? And then apart from that, we are saying we're having at portion number So this is portion number 1, portion number 2. So at portion number 2, we're having a double bond. So that 2 can indicate the double bond where it is, isn't it? Okay, so at portion number 2, we are having En. The double bond is a substituent, so we're having En at portion number 2. Okay, so we can say this is going to be 2 propa or propino, like that, isn't it? Or we can say this is a trans, okay, the other way. Then we are having 3 phenyl, like that, okay. Then we can say phenyl plop. Now I want to indicate the En to be at portion number 3, so I'm going to say 3 En, then I can end with the no, like that, isn't it? Or if I want, I can also indicate that at portion number 1, that's where my aldehyde group is. So either ways, this way or that way is going to be correct, okay. Also, apart from the trans isomer, I can use the E or Z isomer. So now when I'm using the E or Z isomer, I have to indicate the position where my E and the Z is. So you can see the double bond is at portion number 2. So you can say 2, this is an E. We are getting at groups on the different sides, isn't it? Or same atoms on different sides. So we are going to get it at portion number 2. We have an E isomer. Okay. Then I can say this is 3 phenyl. Okay. Then 2 propino, like that. Okay. Or I can also use this one here, just indicate 2E there. Okay, so that's what I'm having. So all these names, that's how we can get our Iupac names for different hydrocarbon compound. Okay, so this is just part of the questions that we had in tutorial sheet 6. So let me just show you the entire tutorial sheet. Okay, so this is a full tutorial sheet. You can see there the questions from question number 1. They are available on the website. Okay, so starting from question number 1 to question number to question number 6. And then again, this is the table I was talking about for the periodicity. So you'll be given this table in an exam. Just make sure you scroll down the paper. Okay, so you're going to see this this guideline at the end. So this one's the one that tells you which functional group is having high priority than the other. So you should be able to use it in an exam there when naming your hydrocarbons, isn't it? Okay, so these are the questions that this is the tutorial sheet that I was solving and the questions that are in there, isn't it? So if you want to get the full video solution, you can access them on the website. Okay, so if you're using an Android phone, you can download our app on the Play Store. Okay, then you just say Discrete Learning Institute. Then you're going to see the app there. So you go to the app. It will show you the courses that are available. So you can subscribe for chemistry. Once you subscribe for chemistry, you should be able to open a folder like this. Okay, so now there will be a folder for chemistry. You open, then it will show you where it's saying general chemistry. You go where it's saying general chemistry. Then it will also give you other options where you're going to have topic lessons and other folders. So you go in the folder written tutorial sheet and assessment. Okay. Then when you click there to give you different universities, so you pick your university, UNAS. Okay. Then when you click there, you're going to notice that it's going to show you a semester. So you pick your semester, first semester, but in this case, this is second semester tutorial sheet, isn't it? So you go in second semester, then you are going to go in the folder written January intake. Okay, so you click in that folder, you're going to see these tutorial sheets that are available there. Then you can go in tutorial sheet 6 there, where it's saying organic chemistry there. Okay, so you open, you're going to find the full video solution for this tutorial sheet. Okay, so thank you so much for watching this video.